So today we are going to review SOHCAHTOA and do some basic calculations, and then the next day we're going to do some word problems. Please make sure you put your name on all of your pages. In fact, not just your name. Please put your full name first and last, and if you could even write the period, that would be really helpful. So let's just review parts of a triangle. So it says label a triangle with the correct sides, either hypotenuse, opposite, or adjacent. And the key right here is relation to where theta is located. So across from my 90-degree angle right here is always the hypotenuse. And by across, I mean I'm going to go across the triangle like that. It's always the hypotenuse. So here's my theta right here. With reference to my theta, the side right next to it is the adjacent. I don't have to go across the triangle. I'm right next to it. And then opposite means I had to go across the triangle like this, and so this one is the opposite. So let's practice again with some actual side lengths. So before we start, the angles A, B, and C are located or labeled. A, B, and C, we use capital letters to name angles. So this side right here, the side between A and C is called AC. This side right here is called BC. And this one right here is called, AB, like that. You could call it CA instead of AC. Those are equivalent things. So which side is the hypotenuse? Remember, the hypotenuse is always across from the right angle. So the hypotenuse is AC. And my angle theta is right here. So we've already done AC, so let me highlight it off. So if I look at theta that I just highlighted, the thing right next to me is AB, so that would be the adjacent. AB is the adjacent. The thing across the triangle, I have to go through the triangle across it, is BC, and that's the opposite. So go ahead and pause the video for a quick second, label the sides, and try the next triangle, the PMN triangle. So this side's called PN or NP. This one's called PM or MP. This one's called MN or NM. The hypotenuse is across from the right angle. So the hypotenuse is PN. Here's my theta. The thing next to me is the adjacent PM. The thing across the whole triangle is MN, my opposite. So what are my trigonometric ratios? So a long, long time ago in geometry, you learned this acronym SOHCAHTOA. And SO, the first piece, the SO piece stood for sine equals opposite over the hypotenuse. The CA piece was cosine. Cosine of theta is equal to the adjacent over the hypotenuse. And the TOA, the tangent is equal to the opposite over the adjacent. So it's really important you know this, SOHCAHTOA, because we're going to use it to solve some triangles. So let's go to the back of this page. So let's practice using the SOHCAHTOA. So on the first triangle, so how do we use these ratios? So if I want to find sine of theta, here's my theta angle right here. So sine is the opposite over the hypotenuse. So before I really do anything, I like to go to the triangle and I like to label it. So let's label our triangle. So across from my right angle is the 5. This means the 5 is the hypotenuse. And the hypotenuse is always the longest side. So if you look at those side lengths, 3, 4, 5, 5 is the biggest. The hypotenuse is always the biggest. One thing to note, SOHCAHTOA is only used on right triangles. And all of these triangles on this paper are right triangles, triangles with a 90-degree angle. Next to the theta is this 4. So the 4 is the adjacent. And then I have to go all the way across the triangle to get to 3. So this thing over here is the opposite. So now that we have them labeled, sine is the opposite. So my opposite was 3 over the hypotenuse, which is 5. So sine of theta equals 3 over 5. Cosine is the adjacent over the hypotenuse. So my adjacent was 4, and my hypotenuse is 5. Tangent is the opposite, the 3, over the adjacent, which is 4. So let's go down below and try again. I'm going to do the first one, I'm going to let you pause the video and try the second one. So to do this first one, we're missing a piece. So first of all, let's label what we have. Here's my angle. This yellow thing next to it is my adjacent. I am next to it. I go across the triangle over here to the 6 to find the opposite. And I am missing the hypotenuse. I'm missing over here my blue friend, my hypotenuse. Well, this is a right triangle, and if you remember, right triangles use Pythagorean theorem. So Pythagorean theorem says a squared plus b squared equals c squared. You've been doing trig for a while, so you can do the x squared plus the y squared equals the r squared, or the hypotenuse. Either way, it's still Pythagorean theorem. But you take one leg, the opposite or the adjacent, and you square it, and you add it to the other leg squared, and that's going to be the hypotenuse squared. So I'm going to get my 6 squared plus my 7 squared is going to equal my hypotenuse, my h squared. This is 36 plus 49 equals h squared. So this, when you add these together, is 85. 85 equals h squared, and then you square it both sides. So the square root of 85 equals h. And if we could simplify this, we would. For the example, if like we had the square root of 200, 200 is the square root of 2 times the square root of 100, and the square root of 100 is 10. So this would be, this would be root 2 times 10. However, the 85, it doesn't simplify. So we're going to leave it as a root, but this is just a thought. Remember, if you can simplify your root, you're going to need to. So now that I have my hypotenuse, I know that this hypotenuse over here is the square root of 85. And now I can go in and I can find the missing pieces. So on the first one, opposite is 6. Hypotenuse is square root of 85. And we don't leave roots in the bottom. We have to rationalize that. So we multiply by root 85 over root 85. So my final answer is 6 root 85 all over 85. The next one is the cosine. So I'm going to do the adjacent, which is 7 over square root of 85, which again, we can't leave. We have to rationalize. We multiply by root 85 over root 85. That gets us 7 root 85 all over 85. And then tangent is the opposite, the 6 over the 7. So go ahead and take a second, pause the video, do just the Pythagorean theorem piece and find the missing piece of the next triangle. Unpause the video and check, and then let's go through and find the trigonometric ratios of that triangle. So in this triangle, my theta is right here. This is the adjacent, the thing next to me. This is my opposite. If I want to find my h over here, I'm going to do 8 squared plus 12 squared equals h squared. So this is 64 plus 144. This comes out to be 208, which is equal to h squared. And then we have to square root both sides. And so let's see if there's something that goes into here. I think 4 might go into there. Let's try 4. I'm just going to use a calculator and do this. So 208 is, oops, sorry, not 5. 208 is 4 times, times 52. So let me see if I can't find something else. So we're going to keep going until I get down to prime numbers. This 4 is 2 times 2. 52 is 4 times 13. So 2 is a prime number, 2 is a prime number. 4 breaks down into 2 times 2. and 13 is a prime number. So I can rewrite the square root of 208 as the square root of 2 times 2 times 2 times 2, the 4 2's times the 13. This is the square root, so that says I need to make groups of 2 to make any one come out. So this is a group of 2, so 1 2 is going to pop out. This is a group of 2, so another 2 is going to pop out. And then inside the root, I'm left with the square root of 13. So the red 2 times the blue 2 makes 4 root 13. So h equals 4 root, oops, I forgot to write the 4, sorry. H equals 4 root 13. So this h equals 4 root 13. Okay, so sine is the opposite, the 12. I want to change a different color. So the sine is the opposite, the 12 over 4 root 13. I'm going to reduce this to 3 over root 13 first, because the 12 divided by 4 is 3. I'm going to rationalize and do root 13 over root 13. This gets me 3 root 13 over 13. Cosine is the adjacent, the 8 over 4 root 13. 8 divided by 4 is 2, so this is 2 over root 13. Then we have to rationalize by multiplying by root 13 over root 13. This gets me 2 root 13s all over 13. Tangent is the opposite over the adjacent, so my opposite is 12, my adjacent is 8. We need to reduce that fraction. 4 goes into 12 and 8, so 4 goes into 12 3 times, and 4 goes into 8 2 times. So let's go to the next page, which is your homework page. And on this page, it's got a front and a back. It's got 16 problems. I'm going to go through in this video, and I'm going to do the odds. And then you're going to go back. I'm going to do some of the odds. And then you're going to go back, and you're going to do the evens. This paper is going to be due on Friday when you come to class. Okay, so let's start with number 1. Number 1 says, first of all, I want to read the directions, and it says round to the nearest tenth. So the nearest tenth, just in case you don't remember, it's like 10.1. The tenth is that first decimal place. So on number 1, my angle right here, this 11.7 is my adjacent, and this x over here is my opposite. So what trig function uses opposite and adjacent, or adjacent and opposite? If you're having trouble remembering, let's make sure we write down SOHCAHTOA. Let me go back just a little bit. Number 1, I should have told you, please put your name, your full name, first and last name, please, and your class period, because you're going to turn this paper in. And at the top of the page, let's write SOHCAHTOA. So which one of those things has the opposite and the adjacent? Well, it's the tangent. Tangent of theta equals the opposite over the adjacent. So tangent of 70 degrees equals my opposite x over my adjacent 11.7. To algebraically solve this, you're going to multiply both sides by 11.7. So I get 11.7 tangent of 70. Please don't forget your degree symbol equals x. So I'm going to put this in the calculator. So when I grab my calculator, you always want to go over here to New Documents. It's going to ask you if you want to save. Please say no. And I'm going to add a calculator page. So my calculator's in radians. Yours up here probably says RAD. You can click here and change the RAD to a DEG, or you can click right here, the unsaved part, and go down here and go to Settings and Status and do Document Settings. And the second one down says radian. I want to change mine to degree. And you're going to have to do that every time you open a new document. So I'm now going to type what we had, which was 11.7. I press the trig button to get the tangent. And then I'm going to do 70. And out of habit, I always press the pi button down here. And I always put the degree symbol. I like to type it just the way they tell my paper, so I always make sure that I have the right stuff. So the answer is 32, and it said round to the nearest tenth, so 32.1. So I'm going to take this video, put it in the corner for later, and then x equals 32.1. So let's try the next one. So same process. I'm going to start by labeling the triangle. So here's my angle. This is the adjacent, the thing next to the angle. This is the opposite. Oh, this is just like the last one, opposite and adjacent. So I'm going to do tangent again. So tangent of an angle equals the opposite over the adjacent. So that gets me tangent of 31 degrees equals my opposite x over 4.2. You want to multiply that 4.2 over to the other side. So x equals 4.2 tangent of 31 degrees. And so since all of us don't necessarily have this calculator at home, let's try. Okay, so let's try. So not everyone has the fancy calculator at home, so you can download this free Desmos calculator, Desmos Scientific. There's the, oops, hang on. When you open it, you'll be on this screen. So there's sine, cosine, tangent. If you click function, there's your arc functions, and then you can switch between degree and radian. So I like this one a lot, but if you don't want to download the app, that's fine. Your phone is a scientific calculator. To make this work, though, you do have to flip it sideways. So if I want to do this in my calculator, a couple things. First of all, sine, cosine, tangent are our trig functions. Sine h, cosine h, tangent h are the arc functions. To do this, though, you have to type the angle first. So on the problem, we just said it was 31. Then I have to press tangent, like I want tangent of the 31 degrees. And then you're going to multiply that by, my 4.2. Remember, round to the nearest tenth, so the answer is 2.5. So now that we have that, I'm going to shrink that down and put it right there. So the answer for number 2 was, changing my screen background, x equals 2.5. So there's number 1 and number 3. Let's go to number 5. I just want to put this one over here too. So number 5. Number 5, here's my angle. And with reference to my angle, this is the hypotenuse. It's across from the 90 degrees, and this is the opposite. So what trig function uses hypotenuse and opposite, or opposite and hypotenuse? It's sine. So if we do this one, it's going to be sine of my angle equals the opposite over the hypotenuse. So sine of 46 degrees equals my opposite 8 over my hypotenuse, which is x. So this time I'm going to multiply the x over to both sides. And when I do that, I'm going to go over here because I'm going to run out of space. I get x sine 46 degrees equals 8. Well, I want to solve for x. So I'm going to divide by sine of 46 degrees and divide by sine of 46 degrees. So in my calculator, if you're using like the school calculator, you can do the fraction, but it's 8 over sine of 46 degrees. If you're using your phone calculator, you want to find sine of 46 degrees and write the answer down, and then do 8 divided by and type that answer back in again so you can put it in the right order. So I'm going to type that in really quick. And when you round to the nearest tenth, you should get 11.1. Let's try number 7. Okay, number 7 slipped around, but we got this. So here's my angle. Across from the right angle is always the hypotenuse. This x is next to me, so this is the adjacent. So that's going to be a cosine. So cosine of a theta of an angle equals the adjacent over the hypotenuse. So cosine of 33 degrees equals my adjacent x over 12 my hypotenuse. I'm going to multiply the 12 over to both sides. You're going to get x equals 12 cosine 33 degrees. And when you type that in the calculator, x, and make sure you round to the nearest tenth, x should equal 10.1. So you could pause the video at this time if you want and do the evens, the 2, 4, 6, 8. I'm going to go to the back side, and the problems on the back are just a little bit different. So I'm going to do the problems on the back for you, and then you will finish this worksheet. This worksheet is due again on Friday. So on the back, first of all, the directions says round to the nearest tenth. So again, 1 decimal place. But this time we're finding an angle. So here's my angle. With reference to my angle, this is the adjacent, the thing next to me. This is the opposite. This is the hypotenuse, but I don't have the hypotenuse. There's nothing there, so I'm going to cross that back up. I don't want it. We're going to ask ourselves the same question. What trig function uses adjacent and opposite, or opposite and adjacent? And so the answer to that question is tangent. So tangent of theta equals the opposite over the adjacent. I don't know the angle, so tangent of theta equals my opposite, which is 6, over my adjacent, which is 10.5. I'm trying to find the angle. I'm trying to solve for theta. So if I want to get to theta, I need to undo tangent. And you can't divide by tangent, but to undo him, you can do an arctangent. And if I do it on one side, I have to do it on the other side. So these two right here undo each other, and you're left with just a theta. And then remember, I had to do the arctan on the other side. So arctan of 6 over 10.5. So you can just type that in your calculator. You can grab the arctan out of the trig and do 6 divided by 10.5. Make sure you've put your calculators in degrees, though, so that it spits out a degree answer for you. When you get the answer, you should get to 1 decimal place, 29.7 degrees. If you're putting this in your phone calculator, you need to do the 6 divided by 10.5 first, and then press that tan H button. Let's try another one. So here's my angle. This is the hypotenuse. It's across from the 9 degrees, and this is the thing next to me, so it's the adjacent. What trig function uses adjacent and hypotenuse? It's cosine. So cosine of theta equals the adjacent over the hypotenuse. So cosine of theta equals the adjacent, 7.8 divided by 11. Again, I want to get to theta. So I'm going to undo cosine by doing arc cosine. And if you do it on one side, you have to do it on the other side. These undo each other. So theta equals arc cosine of 7.8 divided by 11. So when you type that in your calculator and you get out 1 decimal, you should get 44.8 degrees. Okay, on the next one, here's my angle. This is my adjacent, and this is my opposite. So tangent of theta equals the opposite over the adjacent. So tangent of theta equals 11.5 over 16. You have to arctan both sides so you can get to that theta. So theta equals arctan of 11.5 over 16. And when I type that in the calculator, theta should come out to be 35.7 degrees. Okay, last one, and then you will be on your own to do your homework, and you're welcome to come to tutorials and get help if you need it. So here's my theta. This is the hypotenuse. It's across from the 90 degrees, and this is the opposite. Sine of theta equals opposite over hypotenuse. So sine of theta equals 13 over 15. I'm going to arc sine both sides. These undo each other. So I'm left with theta equals arc sine of 13 over 15. So theta is going to equal 60.1 degrees. So you're going to complete this worksheet for homework, and it is due Friday when you come to class.